Okay, let's get started with lesson 7.3, multiplication properties of exponents. Just checking that was working. Okay, please write it down. Simplifying exponent expressions. An exponential expression is completely simplified if. Okay, here are a whole bunch of rules. They are all in your book. Just copy down these rules, please, in as short of a limit as possible, as few words as possible, I should say. But they are things you should be able to recognize on your quiz without any notes. All right, with these, I have the words explanation, but I also would prefer that you write down what's on the bottom here, which is mathematical speak, specifically right here. So that tells you when you have the same base, that's represented by A here, and the exponents are different, they could be the same, and the bases are being multiplied together, that means you add the exponents. Okay, so here are the first 4 examples. Please write them down. All right, so let's get started. 3 squared and 3 to the 5th have the same base of 3. And then you just add the exponents together. 2 plus 5. So the answer is 3/7. For B, we have 2 different bases. We have 2's and 3's. So I'm going to circle the 2's and leave the 3's not circled. You can't combine different bases. So for the 2, I do 4 plus -2, which is 2. And then I still have times 3, and I add those exponents together. 4 times 2 is 2. So my final answer, 2 squared and 3 squared. For letter C, I have 2 terms with Q as the base. So I'm going to keep Q. I'm going to add the 2 exponents together. 3 plus 6 is 9. And the R stays squared. You can put multiply between. You don't have to. With numbers, you typically do keep the multiplication sign in between. Sorry. All right, so with letter D, all of the bases are n, so I'm going to keep n here. 3 plus -4 is -1. And don't forget, when you have a base with no exponent, the assumed exponent is 1. So I ended up having -1 plus 1, which equals 0. And as we know, and hopefully we'll never forget the rest of our lives, anything to 0 power is 1, assuming n is non-zero. So that is how you would work all of these problems. All right. Here's a word problem for you. Probably knew it was coming. Light from the sun travels at about 1.86 times 10 to the 5th miles per second. It takes about 15,000 seconds for the light to reach Neptune. Find the approximate distance from the sun to Neptune. Write your answer in scientific notation. All right. So, we already have the travel here. This is per second. However, we want to know for 15,000 seconds. So I'm going to turn that into scientific notation as of 7.2. So that means I need a number between 1 and 10. 15, if I put the decimal here, is too big, so I'm going to do 1.5. In order to have the decimal between the 1 and the 5, I had to move it over 1, 2, 3, 4 spaces. All right. When you are multiplying scientific notation, you're going to multiply the first number together and then deal with the exponents later. So I'm going to multiply 1.86 times 1.5. I get 2.79. And here we have 2 exponents. We have 5 and we have 4, where both of the bases are 10. So the base stays 10. 5 plus 4 is 9. And of course, we're not going to forget the units. Miles. Okay, here's our next rule, power of a property. Again, I would prefer if you wrote this part down. It's really hard to do it with typing, but sometimes the problem would look like this, a to the m, and n is an exponent. So when it's an exponent to an exponent, or a power to a power, you multiply the two together. So let's work on some of these together. So the base stays the same, and you multiply the exponents. 2 times 4 is 8, so it would be 5 to the 8th. B, it doesn't even matter because it's to the 0 power. So anything to the 0 power is 1. No discussion. Here we're combining both powers and multiplication. So here we're going to end up multiplying these. We have x, 3 times negative 5 is negative 15, times x to the 4th. Because the bases are multiplied, I'm going to add the exponent. So I have x to the negative 11th. If you thought we were done, you forgot our rule from 7-1. You can't have any negative exponents. So this negative sign is going to bring it down, or if you can consider this goes up and becomes the division line. So the answer is 1 over x to the 11th power. Okay, we have another rule here. If a and b are any non-zero real numbers and n is any integer, then ab to the n equals a to the n, b to the n. I see this as distributing the exponent. Whatever exponent's on the outside is going to go to both of the inside exponents. Okay, let's try it. This squared is going to go both to the 2 and to the y. You'll notice that the negative sign is on the outside, so that is not going to be the squared will not be applied to it. So the negative is going to stay there. 2 squared is 4, y squared is, well, y squared. In b, the negative sign is in the base. So third power is going to go to negative 2. Negative 2 to the third power, remember negative base, odd exponent is going to be a negative number. And don't forget that it also goes to that y. All right. With C, and you'll see in the future with chapter 7, there are multiple ways to go about it. I like to simplify what's inside the parentheses first. Remember, when we simplify, you can't have any negative exponents, so I have to fix this y. Y is to the negative third, which means x to the 6th is going to stay on the top, and y to the third flips to the bottom. And we still have the whole thing squared. We're going to distribute the squared to the top and to the bottom. When we have a power to a power, we multiply. So the answer is x to the 12th over y to the 6th. We also could have distributed here and then moved the y to the 6th to the bottom. Either way is fine. And that concludes 7-3.